Okay, so this one is just titled Linear Equations 12 Part 2. In other words, more examples. So let's try more examples, at least a couple more. I want to make sure that everybody understands how to do this. How about this one? 2x minus 1 over 3 minus x plus 2 over 4 equals negative 5. Again, our goal is to get rid of these denominators here in the bottom, but we need an LCD for this. What is the lowest common denominator between 3 and 4? Some of you guessed really well. Lowest common denominator is 12 between 3 and 4. So this is what we're going to do with that 12. We're going to take the 12 and we're going to multiply by each part in this equation. Minus 12 times x plus 2 over 4 equals 12 times negative 5 on the other side of the equal sign. Just don't forget that part, okay? Well, what does this do? What does this 12 do? Multiplying it by 12? Well, it's going to cancel that 3 from the bottom, which is what we want to do. Because 12 divided by 3, this will become a 4. This multiplying of 12 is going to cancel this 4 in the bottom, because 12 divided by 4 will give you 3. And that's all we got. And on this side is just 12 times negative 5, sorry. So let's rewrite this. Now it becomes 4 times 2x minus 1 minus 3 times x plus 2 equals negative 60. Big example. Okay, let's do the distributive property with this. 4 times 2x minus 1. And this 3 is going to multiply with this x, this plus 2. Okay, so 4 times 2x is 8x over here. 4 times negative 1 is negative 4. I'm going to keep this in brackets for now, because this is going to be a minus 3 times x, which is 3x. And 3 times 2 is 6. Okay? Now, if you remember anything about subtracting polynomials from last unit, you know that you can just turn this into addition and turn these into their opposites. Or you can just apply this negative to each of these 3x and plus positive 6. Okay? Watch what I do here. So if you have to pause and rewind this video, go ahead. This negative is going to apply to this 3x, so he's going to become a minus 3x. This minus is going to apply to this positive 6, he's going to become a negative 6. Okay? And really, okay, if I don't skip a step, okay, remember when we're dealing with subtracting polynomials, we turn this into an add, and we turn these into their opposites. Remember this? Okay, why don't we just do it that way? Turn this into addition, turn these into their opposites. And now we can remove the brackets, which you'll see we're going to get the same thing. See? Okay, so now like terms, remember in polynomials, we got to shuffle those together. 8x, this 3x is going to move beside that 8x, and this negative 4 minus 6 is going to be beside each other. Wow, now we're doing actual polynomials also again. So 8x minus 3x will give you 5x, and negative 4 minus 6 here is negative 10, with negative 60 on the other side. Okay. And now we add 10 to both sides. And now this becomes 5x equals negative 50. Finally divide both sides by 5. So x equals negative 10. Wow. I know, very involved. Let's do the check. Is our answer really equal to negative 10? Well, let's find out and let's do the substitution with the original equation, which is 2x minus 1 over 3 minus x plus 2 over 4 equals negative 5. substitute this negative 10 where we see this x. Okay, so this would be 2 times 10 minus 1, still in brackets. Bracket, oops, this is a negative 10. Negative 10 plus 2 over 4 over here. And is all this, in other words, going to be equal to negative 5? I hope so. Let's do these brackets first. So inside this bracket is going to be negative 20 minus 1 over 3 minus, inside this bracket is going to be negative 8, because negative 10 plus 2 is negative 8 over 4. Still waiting to see if this is all equal to negative 5. Okay. Negative 20 minus 1 is negative 21 over 3 minus negative 8 divided by 4. And yes, you can take a shortcut here this time. We don't need to play with common denominators if we don't have to. What is negative 8 divided by 4? That's negative 2. What is negative 21 divided by 3? Oh, that's negative 7. Oops, I'll let that equal negative 5, negative 5. Wow, look at it's negative 7 minus negative 2. I'll just give it negative 7 plus 2, which is equal to, guess what? Negative 5. Okay. One last example, and I hope this last one hammers it home. If you don't need another example, then I guess you can stop the video anytime you like. Here comes your last example. This is example number 4. Okay, so 3y plus 5, this is a y, over 3 minus y minus 3, let's put these in brackets, all 6 equals negative 2. Yep, no, we haven't done this one yet. Okay, let's try it. Again, need to get rid of these denominators in the bottom. I think the common denominator between 3 and 6 would be 6 again. So I'm just going to multiply each of these terms with this 6, like so, minus 6 times y over minus 3, pardon me, over 6 equals 6 times negative 2 over here. Okay. So again, like some of these examples are going to start looking the same, so if you want to save yourself some time, you go ahead. But if you want to see another example, well, here it is. This 3 is going to be canceled out because 6 divided by 3 is equal to 2. This 6 is going to cancel out because 6 divided by 6 is just 1. Okay, and there goes the denominator. Thank God. So now all we have is 2 times 3y plus 5 minus 1 times y minus 3. Well, that's just going to be y minus 3. And on this side, 6 times negative 2 is negative 12. What's that? 2 times 3y here is 6y. 2 times 5 is 10. And now, what are we multiplying this with? Well, when you have this situation, this actually, believe it or not, is an invisible negative 1 in here. So negative 1 times y is negative y. And negative 1 times negative 3, well, that becomes a positive 3. Yes, invisible negative 1. And now we just shuffle our like terms again. 6y minus y and plus 10 plus 3 equals negative 12. 6y minus y here is 5y. 10 plus 3 here is 13. Okay. Now we subtract 13 on both sides. Now we have 5y here and negative 25 on this side. We divide both sides by 5, and our answer is y equals negative 5. And now let's do the check. The original equation, 3y plus 5 over 3 minus y minus 3 over 6. Is all this going to be equal to negative 2? I hope so. Substitute our negative 5 where we see that y. So 3 times negative 5 plus 5, still in brackets, all over 3, minus negative 5 minus 3 over 6 equals negative 2. 3 times negative 5 here is negative 15, plus 5, still in brackets, over 3, minus negative 5 minus 3 here is negative 8, still in brackets, over 6. Okay. Negative 5 plus 5 is negative 10 over 3, minus, well, we have to leave this as negative 8 over 6. Or actually, we can actually make this into an addition, because a minus a negative will be plus 8 over 6. Okay. So the problem is we need a common denominator between these two. We can't just reduce these to simpler numbers like our last example. But I know the lowest common denominator between 3 and 6 is already up here. We said it was 6. So how do we turn this 3 into a 6? We'll multiply top and bottom by 2. So now I'm going to get negative 20 over 6 here, plus 8 over 6 here. Is this going to still be equal to negative 2? Well, now we can actually add the numerators. 20 plus 8. And negative 20 plus 8 is negative 12 over 6. And it is correct because we do get a negative 2 equals negative 2 on both sides, because negative 12 divided by 6 is negative 2. And there we go. It's been a good year. We're going to miss you all. And I hope this video helps you with this last assignment. And I hope your teachers take care of you in grade 10, 11, and 12. But come visit anytime when this COVID situation has been nullified and cleared and we get back to normal. We'll see you grade 9s.